Alright, so you won't get to see my lovely face, and I won't get to see your lovely faces, but I want to go through this information, and yeah, I probably could just, for instance, tell you, start watching the talking heads, right? Start watching these guys and take notes on those and turn them in. But whether or not I'm right or wrong, I think I point out some things that are more important than they do. So again, if you find yourself in need of help, and what I'm telling you is not enough, and the fact sheets are not enough, then please watch the videos. You won't get points for them, but you watch them. You need to take notes on what I'm telling you here. So that it's going to be a little difficult. I'll try to keep the pace slower, but I know this presents some problems. So I'll be, kind as we get going on this note taking, virtual note taking. But yeah, you need to take notes on what I'm telling you here, and then go ahead and post that out there. I'm going to go through all of switch management today. And so I've got the list over here in our course shell of what we're doing. You actually won't, right? We're not doing 11 and 12, 14, 15, and 16. We're not doing any of those. These are what we're doing. So 6, and I'll put now due on each one of those. I want you to know that the tests are stopping after 5. So you won't be taking those tests anymore. Now the reason I do that is because there's going to be a final, and that final, as you know, is worth quite a bit, and I want you to start studying for that. And so as you go through this, don't just slack. Don't just say, well, I don't have to really look at 6. Well, you will because that's going to be part of your final, right? And so it's common in this business to have this big set of questions that you have to go through and run through them. And so I'll break them down. I'll have, here's your stuff over 6 and 7, for instance, and 8 and 9, or however I decide to break it down. But you'll need to start testing yourself with that, even though those things are just prep. It's going to come down to the final, and if you're not prepping correctly, then you're not going to be able to pull an A in the class, because that final will really hurt you. So let's get started with switch access. So definitely take a look at use the command line interface, and remember, in order to get points for these, you can't just click on them and watch them. I'm actually looking at how long did you actually watch that. Good stuff in that one, and that means I don't have to actually pull that up and show you that stuff. So let's take a look at switches. Now we remember that switches are the things that connect everything together. If I was to ask a question in class, I'd say, which layer do switches operate at? And I would pause and hope that one of you would say layer 2. You can get layer 3 switches, but layer 3 switches use IP addresses for very little. There's usually some quality of service stuff that they're doing, but everything else is happening at layer 2. So switches are concerned with MAC addresses, and how they actually function is by bringing together all of these MAC addresses that are being broadcast over all of these different connections, right? Because switches have all these ports, and you're plugging all your lines into these ports, and they're reading the MAC address off of that. So when your computer comes up and it says, I'm looking for such and such printer, not only does it learn what the printer's MAC address is, but it learns what your MAC address is. And we really call that a micro collision domain. Switches stop the problem with all this data being thrown everywhere. They look at your MAC address, and they look at what MAC address you want to talk to. And then it connects those two together. It switches the fabric in the back. And it has to have a lot of bandwidth on that back side of it to make that happen. And so that's primarily what it's spending its time doing. So you have to really think about the fact that, again, I've explained this in the past, but it's like you have a chance to get on the road and go to work or come to class. And what the road does for you is connects the pathway between your house and the school. And then you travel along that with no interference whatsoever. Meanwhile, somebody else is traveling on a different road going to their work, and it lets them travel on that road without any interference. So big time switches that you would use in companies, are extremely expensive. Just to kind of show you, let's go to CDWG. They're a big reseller. And let's look at our hardware here. Let's forgive my scrolling because I'm using this touchpad and it's not working too well. Alright, so where are we? Networking products. Transceivers, controllers, wireless routers, where there's our Ethernet switches. So we want fixed managed switches. That's usually what people are using. Okay, so there's a Cisco 48 port. That's all it's got on it, and it's going to cost you $7,000. These are just little ports. These are things that go into them, right? That's just one little section. There's a Cisco Catalyst. Now Cisco's usually more expensive, and so if we come over here, HP is actually very much in demand. They sell a lot of stuff. So we'll get down there. HP. And whoops, I was going to grab their other one too. So there's an Aruba. That's $44,000 managed rack switch. $31,000. So why these are more expensive is a lot of reasons, but mainly because there's this switching fabric that allows each and every one of those ports to connect to the other, so that this port can connect to this port over here. And that fabric inside has to be able to push the data that it's supposed to be. So for instance, cheaper switches will say, oh, we like the ones I have, those are cheaper. They'll say, oh, this is a gigabit port and it's got 24 of them, but doesn't have 24 gigs available in its fabric so that each port really could do a gig. Most of the time, no. Instead, it'll say, oh, well, it's got a 12 gig switching fabric. Okay, well, if I plug in 24 gig ports, then what it's banking on is that not all of them are being used at the same time. Because if they're all being used, my speed is actually half of what it should be, right? And so they're very expensive in big environments. In the home environment, we just get a little switch on the back of our access point, our wireless router, as they call it. Those things are pretty advanced. I mean, there's a portion of it that's a router, there's a portion of it that's wireless, and there's a portion of it that's a switch. So they're pretty advanced, but they're not really set to push a lot of data through there. And that's usually a common issue. You see people and they'll try to do these gaming LAN parties, and they don't have switches that are capable of pushing that kind of data, and they crash and everything. Anyway, sorry about moving on to more important things here. So you can either have an unmanaged switch or you can have a managed one. Oh, and I'm sorry, you can't see my mouse probably with this thing. So I'm there in the top paragraph, an unmanaged switch and a managed switch. Unmanaged means that basically it does everything on its own. You just plug it in. And as computers come online and start talking to one another, it learns everybody's MAC address and it knows which port to send things to. If it gets shut off, it learns that all over again dynamically, which is no big deal because the stuff's traveling at near light speed, right? So it learns it all over again. That's not a problem. Even managed switches do that. But managed switches, you can go in and you can actually set the port. This is one of the things that we were going to do in class. You can go in and say this port is more important than the other ports. So always put it above all the others. That way your boss always has a great connection. Managed switches means you can go in and manage them. And when we talk about VLANs, that's one of the things you can do. Anyway, now there's in-band management and there's out-of-band management. Now in-band management means that it's actually part of your network traffic. So if it's in band, that's a term that means it's part of the traffic. Out of band means it's not part of the traffic. In security terms, in band communications mean that it's something that is part of what should be there. Out of band communications means that somebody's going outside of what they should be doing. So different usage, but still the same thing it's talking about. So there's several drawbacks with in-band. You must compete with normal network traffic, right? So you're sending the data through the normal network traffic. The network traffic created by management utilities must have protection from sniffing attacks. So again, you're going to get onto that switch and you're going to type in a username and password. It better be encrypted. Otherwise, somebody on the network could be seeing that. And then if the network connection is unavailable, then you can't get to it, right? So now out-of-band management, that just means there's a built-in serial port or there's a USB port attached and you plug right into it. And you're not using the network bandwidth, you're actually just plugged into it using something else like a USB port, and you're accessing it through that. And that's out-of-band communications. Most places, because of ease of use, will use in-band communications and configuring, and then if things got bad, right, they walk over to the switch and they plug into it, and that's out-of-band communications. Now, they give you the connection type, how do you connect to it, and I'm not going to go through that. But they do use a special cable type, which is a rollover cable. So Cisco started this. I don't know why they did it, but they do it. And so you'll have like a USB connection on one end for your computer and then a network jack on the other end for your switch. It's kind of strange, but they roll it over, right? So 1 goes to 8, 2 goes to 7, and on down the list. It's strange. And then of course they show the other ones, which are straight through and crossover cables. So main thing that you need to know out of that is that when you want to manage a switch, get on the switch, you can either do it through the network in band, or you can do it outside the network, out of band. And when you're doing it out of band, you're probably going to use a rollover cable for that. And it also depends on the type of switch. Maybe it's an RS-232. They all have their own little thing, and that's something that you learn on the job. All right, so moving on, we're going to go to switch IP configuration facts. Normally all of this stuff, and you get to do some of this, which is cool. It really is cool. Normally where is my VLAN stuff? Oh, I'll get there. All right, anyway, so normally you'll assign it an IP. So switches can automatically gain an IP from the network. So they can do DHCP if they're a managed switch. So if it's an unmanaged, they're not doing that at all, right? A switch does not need an IP address. It's a layer 2 device. There's no reason to set up IP on it at all unless you want to manage it. So an unmanaged switch is plug and play. You just plug it all in. Managed switches are also plug and play. You just plug it all in. But if you want to do the management stuff, you got to have an IP address with it. This usually really confuses students. When we actually do this lab, and I guess we may be able to do that, we'll see how many of you are actually interested in doing it. But when we do that lab, students really have a hard time getting that IP and what am I doing here? And they're typing it in their browser trying to access this switch. And it's like, well, I bought managed switches, which allows us to go in and look at what the ports are doing, turn ports on and off, trunk ports, make VLANs, all this stuff. And so it has to have an IP for you to talk to it. Otherwise, how do you make that happen? On an unmanaged switch, there's no need to do that. You're never going to get on it. You're never going to configure it at all. And so you don't give it an IP. So they actually show you, so this is the information you need to know in order to do the labs. Because this is great. I mean, it really is. They just like drop you on a Cisco switch and they're like, do it. This is the ones that I'm talking about where you may actually want to fail, right? You may want to come in and fail this because it's a leap. I'm telling you, it is a leap. We'll look at one of these in a second. And when you fail it, it'll give you the commands you have to type. But let me show you what this is doing, and I'm going to copy this out because I doubt you can actually see my pointer on here. So I've got Word installed, and we'll just dump this text into Word so I can highlight some stuff. There we go. All right, so dealing with this, notice what it says here, switch #, not hashtag, right? I hate the fact, I really do. I'm venting again, I know, I'm sorry, but I hate the fact that the Twitter used a # for their tag. And what that means is when you're talking about a data system, you put that tag in front of what you type, and that helps the system sort what's going on, right? So if I put #James, it'll go into this area where somebody else put #James. This is, you know, the #, and it's used as a end marker, right? So this portion, let me just make this bold. This is what it actually has listed. This portion is what you're typing. Right, so if you were sitting on this right now, and when you get in, we'll show you when you get into the simulation, it'll just say switch #. And then what you would type would be config terminal. And when you hit enter, then it comes up and says switch config #. And you type interface VLAN 1, and it goes switch config IF, that's interface #. Then you type IP address, and you give the IP address with the mask. And then it comes back and says, okay, well, switch config if, it's the same, see? And then you also type no shutdown, right? And then this is to enable management from a remote network. And so let me jump into one of those labs so that you can see what it looks like. This is very, very valuable information, and I'm afraid that because of us going through this terrible process of not coming into school, I know you're like, what? It's not terrible, it's awesome. That people will miss this. They'll just go, you know what? I have no idea what's going on here, so I'm just going to get through it and not really try to learn what's happening. If you're interested in doing this kind of work, then pay as much attention to this as you can. Okay, so I'm not probably going to finish this whole thing, but it wants us to configure VLAN 1 interface with the following IP and subnet, and then configure the switch to use this IP as the default gateway. And then we're going to save our changes. So you see that you're like, what are you talking about? So if you have that information saved, or someplace you can see it, right? This is where we're at. I can type config terminal. See, what did I do? Config, is that correct? Did I do that right? Yeah, that should be right. Config terminal, because I'm not in the config yet. See? Oh, I probably don't want terminal. Let's just jump to config. Nope, doesn't like that either. Transferring config. This is not really helping me. So what I would do at this point is go, you know what, I'm done with this. And then what it's going to do is show you. Oh, okay. This is what I was supposed to do. I selected the switch, I hit enter, and then I was supposed to go enable. That wasn't part of my other instructions. Why wasn't that there? And so you can actually print that, and it will come up, and I can just leave, you know, say print that as a PDF, which is just fine, and I will stick it on the desktop, and we'll call it temp1. That'll remind me to get rid of it. And then I can kind of go through and see what's happening with it. To me, it's actually very helpful. I wish I'd had something like this when I was trying to get my work done. Oh my goodness. Apparently there is just too much on this desktop. So there's my tax stuff from 2020. There's temp1. Let's open up my tax stuff. Oh, No, we don't want to do that. Okay, so here's my commands. So this is the prompt that it's at right there. So I need to do enable, which honestly I should have remembered because I used to do this crap all the time. Where's my test out? There we are. So we click that, we press enter, and we type enable. I used to love doing this stuff, man. I cannot tell you. I'd almost look for reasons to do this stuff, even though I didn't need to do it. All right, that's right. It's right here in the browser. So then the next one is configure terminal. That's where I got that. I needed to enable it first. And see how it switched. Now it's switched, and now I'm in config. Used to be able to command, I can't remember what it is, directory, help. I think that's what it is. Yeah. No, that's still not it. Show PR. Oh yeah, the show command. Totally forgot. Okay, I'm really getting distracted here, so I will stop. The main thing that I wanted to, not getting anywhere. The main thing I wanted to show you is the fact that it does do good to stop it and see what you're supposed to type. And as you're going along with it, notice how the prompt changes. It's interesting the way they do it. The way they configure switches and routers is like you're going into these subdirectories. And so when you type interface VLAN 1, now you're in the interface directory. For what? For VLAN 1. That's the interface you're on. Then you type this in, and that issues that command. And now you can exit it, and now you're out of the interface config. You're going back now. Whoops. I'm sorry. I should be highlighting this stuff. And I can't. That's not nice. I can't even select it. That's not being very helpful. Let me go to draw. All right, so what I'm talking about is watching this portion here change. And you can see that right here you're in config interface, and then once you hit exit it takes you back to config, and then once you hit exit in that it takes you out of config all the way back to switch. And that's something that you're going to be doing a lot of. And if you're watching this, then this becomes much more apparent of what's going on here, right? What's happening. Okay, so I enable it. I can now configure the terminal. That puts me in config mode. I can now deal with interface VLAN 1. And what do I want to do with that? I want to give it an IP address of this with a subnet mask of that. Now I'm done. I want to exit it. And I want to now deal with the IP default gateway. So I'm still in config, and I tell it IP default gateway is this, and then I exit that. And then the last thing, this one, is to copy the running, what I just did, what's running, to the startup config. That's what this means. So copy everything that's running to the startup config. If you don't do this, then when the switch restarts, everything you did is lost, because the startup config is different than the running config. That's another thing that is important. All right, so let's move along. Let's hit done on that. So it is, again, very helpful to just fail those so that you can actually see all the commands that are available to you, because they're not going to be listed. So there you get to configure the IP setup again. All right, so let's take a look at switch forwarding facts. I described basically how this is working. So the bridges and switches, they build a database or a table in it. And sometimes it's referred to as a routing table, honestly. Forwarding database is a list of layer 2 MAC addresses. There is no other kind of MAC address than a layer 2 one. So it's a MAC address for each device. And they automatically learn that by building a forwarding database. And that process is what I already talked about, with the fact that you come online, you ask for a printer, the printer responds. So it got your MAC address when you asked, it got its MAC address when it responded. and it just fills up that table. So anytime that it comes online, it has all that information ready for it. It doesn't come online, it has it already. It's going to examine the destination MAC address in the frame. So it's looking at that layer 2 information and saying, where is this going to? Oh, that's this port. So when you see this kind of stuff, for instance, a unicast address but no mapping exists, then the CAM table for the destination address, the switch floods the frame to all ports. So this process, I'm not going to read through that whole process, you need to, but basically what it's describing is, I have one MAC address, but I don't know this other one, so it just broadcasts it, right? It creates a broadcast, and then somebody responds to that. And then once it responds, and it's like, okay, now I have both of those MAC addresses, and I can now provide communications with just between you two. So it's very efficient at dealing with Ethernet, which is this crazy idea of just letting every computer do what they want when they want. So now with the switch, it means that every computer really can. It can come online, and as long as the switch is not overloaded or too busy, it'll do what it needs for you while doing something else for somebody else. So it's got to have some powerful processing in there, and it's got to have a nice backplane to deal with all of that switching fabric, which they don't really talk about in here. All right, so this is nice. They should have shown you this before. But they're trying to show you, hey, there's different modes in which you can program a Cisco switch. Now, why are they talking about Cisco so much? Because they're the leader in the market, everybody copies what they do, right? If I'm going to be an HP switch maker, I want to make sure that my commands are pretty much exactly what Cisco is going to be doing, so that if you buy my stuff, you don't have to learn a whole new set of information. You can do it the same way you've been doing it. So the best thing to do, just teach students how to use Cisco, and then no matter what they go use, they maybe have to change a little, right? So you've got user exec, and then privileged, and then global configuration, and then down into your interfaces. So really what this is referring to, because you're probably looking at this going, what do you mean? Well, if you're a user on it, you can access all of this within here, but you have to provide the right credentials to get into privileged executive mode. Once you do that, then you can look at global configuration. An example of a global configuration would be the default gateway is this. That's an example of a global configuration. However, you want to actually provide a port with a certain interface information, then you go into the interface itself, and then you can deal with the interface itself. And that's that nested mode that we're looking at here, right? So when you're here on config if, that's configure the interface. When you're here on config, that's configure the global right there. And that's what they're trying to show you visually. So they kind of chucked you in it and then didn't show you the stuff. So there's interface config, see, and this is what you're going to see, your command line interface mode prompt. Aren't you lucky that I started teaching you that stuff in 113? And there's your config VLAN, and this is what you would get in the different modes. So you'll want to refer to this is why this is here. What is this actually doing? Because in your labs, it's going to come up and say, oh, okay, do this. And if you have that, you're like, oh, okay, yeah, I got to do the VLAN, so this is the prompt I should get, right? So that's important stuff. This is the hands-on stuff. I'm always surprised when we get to this point. This is kind of, wow, this is the nitty-gritty of networking. I'm learning something I can actually apply, and then people don't spend enough time on learning it. And they're like, okay, what do I need to know for the test? Let me move on. It's like, well, if you're going to go in and do this stuff, you better pay attention to what's happening. And then here's your command list. So they should have taught you this before too. But there it is. And again, the thing that you need to remember is, where is that pound sign or that hashtag? The hashtag is the end of the prompt. So the rest of it all on the right hand side, for instance, let's look at the top line. Switch bracket config bracket hashtag. That's what it listed. Now you type interfaced fast Ethernet 0 of 14, and that moves you to an interface config mode. And then that'll change it. It'll say switch config fast Ethernet. Right. So this is a set of commands that's very nice to have as you do things. Gosh, I love this stuff. What a bad time not to be present. Probably saving you guys a lot of trouble though, because this is a lot faster than me getting totally distracted half the time, right? All right, so let's talk about what a VLAN is. This is different. It's a virtual LAN. So a real LAN, in reality, a LAN, right? That's a bunch of switches that are all connected with these cables. And in order to be on that network, you got to go plug in that cable, and now you're on that LAN. So let's look at it from that point of view. A virtual LAN is using your electronic equipment to actually separate traffic out for some reason. So it becomes logical. It's a logical LAN instead of a physical one. Now that icon, that little square that they're showing right in the middle with the 4 arrows, that's the icon or the representation of a switch. So if you're looking at diagrams and things, you would look at that and go, oh, that's a switch. A router has got arrows pointing out all 4 directions. So one, north, south, east, and west looks more like that, and it's usually round. And so when we look at this picture, we realize, okay, this is one physical switch, and it's got VLAN 1 and VLAN 2, and it's got 2 computers on VLAN 1 and 2 computers on VLAN 2. It's separated their traffic out. And so in this situation, unless you're bridging it in some way, this FA01 cannot speak to FA04. Those are 2 different LANs. Now, physically they're not, right? They're all plugged into the same switch, but you're telling the switch to split it, to not allow the traffic. I actually had to do this where I worked, where we had the state coming through our network. And the state demanded that we not be on their network, and so I had to create this little virtual network. I could have just bought a little switch, right? So I'm taking their plug-in coming out of the wall, and I'm going straight into my fancy switch, and I'm putting a VLAN together that's just got that port and the one that goes out to their offices, and they're separated from ours. That's the way that works. When you do that, you are giving it VLAN IDs. You're IDing them. One is VLAN 1, one is VLAN 2. You're actually specifying what they are. Now here's the thing that gets crazy. So look at the VLAN switch benefits. Create virtual LANs based on criteria other than physical locations, such as work groups, protocols, or service. Wait. So I can create a virtual LAN based on the fact that Joe in building 1 is part of a work group in building 2. Yeah, okay, that one makes sense. Okay, so I can also create a VLAN for separating traffic and protocols, like IP telephony is on a VLAN and then all the rest of the traffic's on a different VLAN. Yeah. See, then we're not talking about this here. This is an easier thing to understand. When you separate and say I've got a VLAN for my gaming traffic as opposed to my my IP telephony traffic, you see that's based on protocol. So you're not grouping those together by computers, you're grouping it by protocol or service. So simplify device moves. Device are moved to a new VLAN by modifying the port assignment. So that can help. For instance, again, Joe now is moving to building 3, and so he's on a totally different port someplace. You can actually just go in and select it. So that simplifies the management instead of physically having to do something. A good advantage is the control the broadcast traffic. So you're creating these little collision domains within your Ethernet, and it's not going all over the place. You control security, so you can isolate traffic, and then you can load balance the network, and that's usually driven by what kind of protocol it is. Like, we're going to separate this out by protocol, and we're going to say that game traffic that we separated out, that's not so important. But the IP telephony stuff, that's important. And so that's why you would do that with protocols. You could say this one's going to be more important. So anybody that transmits on that protocol receives a higher priority on this switch or on this network. So there's different reasons and benefits, but I tell people all the time, something that I don't think they hound into you enough is that you have to think about where your data is flowing. And so if everybody's getting on the internet and that's primarily the thing that they do, then using different VLANs doesn't necessarily help you. The only time you'd want to start restricting things is for instance, you've got an R&D group, and that R&D group is not separated by a router. So you want to make sure that their traffic is just not broadcasting out there, just in case you got somebody sitting out there sniffing it. So we'll put the R&D on their own VLAN, and it doesn't matter where they are in the network. We can say this port, like port 1, port 10, port 42, port 16, are all a part of this R&D group, and that keeps their traffic more separated. Because some people would say, well, I want to keep the traffic separated, so let's put in a router. Oh, that's true. Yeah, that's definitely something you can do, but maybe you don't have $40,000 to put in that router, so you just do it on your switch, and you say, hey, you're part of your own little virtual LAN. So there's uses for VLANs, but you got to be careful in how they're implemented and understand where the traffic's going and why it's going there. And then here's your command list. So again, I'm not going to read this off, but there's all your VLAN command switch stuff. All this. So when you do those assignments and you're dealing with VLANs, there's your command list for it. All right, now let's look at trunking. What is trunking? I'm just going to keep talking because I know you can pause me anytime and go get a drink or whatever you want to do. So I don't have to say, hey, let's take a break. All right, so what is trunking? Well, if you've got 3 switches and they're all dissimilar, see, I should back up. These kinds of switches, the reason why, for instance, they would go out and buy all HPs is because those HPs would have a special connecting port. Lots of times they use these fiber ports right here, but sometimes they'll have a special connecting port on the back of the machine. And so what that does is it enables the switches to connect at a very high rate of speed together, more than that they would get off of these ports. So there's really a couple of ways to connect the switches. One, through a specialized port in the back that connects to each switch that you have. And you may have a stack of 20 of these, honestly. And they're all connected, daisy-chained together on the back side. And that puts them all a part of the same thing. And they can transfer the data very fast through that port. Or you can connect through the front. And a lot of them, again, they'll include these are a fiber type connection, and that way you can take a fiber connection and run it to the next port. But even then you're probably going to want to trunk things. So let's take a look at, well, what do we mean? Trunking allows you to take several interfaces. Let me go back to this picture. I should have mentioned, but you'll notice that as you type in these kind of parameters, right, we're configuring an interface. And so when you look at that, what is that? Well, these are all interfaces. Every single one of these connections is an interface. And getting to the point now, we can trunk or connect a bunch of those interfaces together. So in this picture, they show this trunk line in the middle. What they mean is that they have plugged in several of those ports together so that this is faster. The trunk lines are supposed to be faster. So if we're plugging them into the back through the special port, then we've got the speed we need. But if we have to plug into the front, then maybe we're only dealing with a 1 gig port, and we've got a 24 port switch, and all of those, right, all run at 1 gig. And now we need to connect it to our email server, which is where everybody's going. Everybody's getting on the email server. Maybe we would do the same thing for our DHCP. Everybody's trying to get to that. And just attaching our email server with one port between the switch and the email server is not enough. And so instead what we do is we trunk or combine 6 of the ports. that are on the switch, and we combine 6 of the ports that are on the email server, and now they all act as one. So now all of a sudden you've got a 6 gig port instead of 1 gig. And so trunking ports together are usually used to gain speed between switches or between servers that need it. And so even on this one that's got these fiber ports, that's why I say you may plug in all these fiber, and each of these is 10 gig. But you're really using 10 gigs on these ports themselves. So you want to trunk this all together so you can have a 40 gig port running between this switch and the next switch. That's what trunking does. So trunking equals speed. Put the ports together so you have more speed. So access ports are connected to endpoint devices such as a server, like I explained, and trunk ports are connected to the other switches. An access port can be a member of only one single VLAN. So basically trunking is a special VLAN is what we're trying to say. But that special VLAN just deals with those ports. It doesn't separate traffic from the rest of the switch. And that's important. Like we talked about VLANs and separating traffic. Well, when you do a trunk port, which is why it's listed differently here, those ports that are trunked together are all going to come into that one VLAN, and then they're going to go out to the rest of the ports that are on that switch. It's not blocked. It'll work. And any port on the switch can be configured to be a trunk port, and by default, trunk ports carry traffic for all VLANs, which is what I just described. You should know that there are tags involved in this, so VLANs have a special tag on them, and that's appended to the first switch and the last. So only switches that understand VLANs will actually get the tag and know what to do with it. So it can still go through dumb switches that don't have any idea what a VLAN is. They just package the data and send it on. And then the switches that do understand the VLAN can read it and know what to do. And IEEE 802.1 is our quality of service. That's our trunking protocol. And so if your switch is compatible with this, then you should be able to trunk to a different switch. Most network operators don't believe in using something that's different because we found that sometimes it's not quite compatible. What this means is that I should have the ability to have HP networking equipment, have Linksys networking equipment, have Cisco networking equipment, and they're all compatible with this standard, so I can use trunking and it's not going to have a problem. In most places they don't even want to mess with that. They just make sure everything's the same. Which is one of the reasons why they do that, is so they don't have to worry about it. Alright, so VLAN Trunking Protocol, VTP, simplifies the VLAN configuration on multi-switch networks by propagating the configuration changes made between switches. So in other words, if I go in and I change, like you're going to do in your lab, and you say blah blah blah, this is on this VLAN, it'll propagate that across. And then you have switches that do different roles. So if you're using that, then well, who's the one that should say that it's okay, right? So a switch, if you're using this protocol, so you can go in and say, oh, this port is now part of this trunk or part of this VPN. It has to serve in server mode, and it can modify, and then it advertises the information to the rest. And then the ones in client mode, they can't change anything, they just listen. And then the ones in transparent mode, they allow for local configuration, but it doesn't update anything, right? So it's just transparent to what's happening. I know it's a lot of information. I think it's like extremely fun. So much fun. Anyway, here's your trunking commands, which I don't need to go through, but when you do your labs, those are the commands you'll use to trunk things. Quite a few labs in there. That's what's going to take some time. And then finally, we're going to end this with a little troubleshooting and some spanning tree. Spanning tree, that sounds really cool. So I know you thought STP stood for something else, but it's actually the spanning tree protocol. So here's the thing. Routers are designed to have multiple paths. Switches are not designed to have multiple paths. And so if if you have a switched network, I should actually just pull up my sketch. Not. Yeah, we'll pull up snipping tool here, and then we'll try snip and sketch. Do new. Let's snip now. So we're going to talk about this switching loop right there. And I'm going to just draw on the screen, which it's not letting me do. That's not nice. Let me pause it for a second. I'll be right back. Somebody's at my door. Okay, well, I guess I have Sketchbook on here from AutoCAD, which that's nice. This is the only advantage to having this tablet running things off of here. But this would be a normal config. So we're going to have a core switch here, and then that switch is going to be connected to other switches. And so it's common to have this kind of tree configuration. And then these can keep going, right? They can have 3 other switches attached to them. And so you end up with this really large collision domain. Now you can tell that, let's say that we lose this switch. Well, that switch is how the other 3 are connected. So basically most of our network has just gone down. Now another way that they configure it, because I don't want you to think that's the only way, is that they'll actually configure it in a trunk, and so they have all their switches in different offices configured in a line. And then that way, see all the computers here connected, here. There's tons of computers connected, and that's how they're connected. And you can, go out further from that and say there's 2 switches on this one, and so on. But the thing is that switches are not designed to have a loop. Because if this computer way up here connected in doesn't know something, it will broadcast it into the switch, and that switch will broadcast it to everything else, and it'll broadcast it to every other computer on the network, right? That's the way that works. Routers, of course, don't work that way. As we learned, routers do not repeat broadcasts. So if you don't know where you're going and it's a router, it just ignores it. Well, you can see in any of those configurations, let me just go back to this one, that if this switch goes down and there was 40 individuals here and 60 here and 120 here, this 40 cannot speak to the 60 or the 120, right? The switch is down. And in networking, we've come to appreciate reliability. So how do we make that reliable? How do we make sure that that doesn't happen? Well, we use spanning tree protocol. Spanning tree allows it to realize when it's getting a broadcast from something it already received. So if we go back to our drawing with spanning tree, what we could do then is we could create another line that comes down and connects to this. See, that way if we lose this one, we can still connect to the bottom 2. If we lose this one, we can still connect. As a matter of fact, if we lose the last one, we can still connect to everybody else. That's the point. But what happens when you get a broadcast? Right? A broadcast is meant to be sent. And so this is something else that we would do in class, is connect the stuff and then create a loop and watch the switch just explode. It doesn't physically explode, but the lights do. It's really cool. And so if you're sitting over here and you broadcast in, and let's say this is the main path down the middle, that broadcast, let me change my color here. I've never used this product, so I don't even know if it has, oh yeah, there it is. So let's go over to blue. So that broadcast comes down the traditional the pathway, hits all the computers, and then what's going to happen? Well, without spanning tree, that broadcast is going to come back up. The switch doesn't know that it's already seen this, and so the broadcast is going to come right over to the computer that it went to and come back down through. And of course hit every single computer that's connected to these switches and come back around. And now it's a whole nother broadcast, and send it again, come down, send it again, come down, and in a matter of seconds the whole network stops communicating. Switches are not meant to accept loops. Spanning tree protocol enables it to try and recognize where the loop is. So if these switches are all running spanning tree protocol, especially the first and the last, not necessarily the ones in the middle, the broadcast comes out, travels down the regular, and then as it comes back through, this spanning tree protocol goes, hey, wait a minute, I already sent that out, so I'm not going to listen to that. Anything coming down this line shouldn't be a duplicate, and you are, so I'm going to stop it. So that's what spanning tree, that's a long way to get around it, but that's what spanning tree is designed to do. Eliminate loops, provide redundant paths between devices, which enables you to not have things go down. When they talk about enabling dynamic role configuration, that means that what if one goes down, can another switch pick up and say, hey, I can deal with the spanning tree protocol. If we go back to our model, if we're running spanning tree and this one goes down, is there another one that can say, hey, I can do that. I'm good enough to actually figure that out. So that's another part of this IEEE 802.1d committee. Enables dynamic role configuration, recovers automatically from a topology change or a device failure, and identifies the optimal path between two network devices. I mean, that's what it's there for. That's what it's designed to do. Most, my brother works in the industry. He usually doesn't have that on. It's been around for a long time, and every year I would, there was updates on my switches, and I would update the switches and then try spanning tree protocol, and it would work for a day or so, and then all of a sudden the network would go down. And it's a very complex thing, and I'm sure they probably got all that ironed out by now, but my brother, who still does this stuff, right, he doesn't turn that on. Instead, they know what to do when a problem exists, and they know what cable to plug in. Right? They know I can plug in this cable and that'll take me down this path. And for them that's reasonable, right? It's like, oh crap, the network's down, and then they run over there and 10 minutes later the network's up. So that's spanning tree though. If it's working right, it works great. And then these are the different components, like what is a root bridge and a designated bridge and a backup bridge. Those are all roles that you give to these switches. And I kind of already described that. It's basically where you say, look, you're the root bridge, so you tell all the other switches what to do. And then the others, right? Whoops. Like designated bridge, any other device that participates in the forwarding of packets but doesn't do anything. And then the backup bridge, the one that's listening to go, oh, dang it, everything went down. Now I'm going to be the root bridge. Right, and so you give your switches these different roles so that they know what they're doing, and then it's got these different port states that allow it to, is this disabled? Is it blocking? Like I said on the other one, hey, you're coming back, so it blocks that. Is it listening for a state to block or learn what's happening? I'm listening to this, hey, that's the same one, so I think I'll switch from listening to blocking now, that kind of thing. And learning. So these are the different states that these ports will be in, and you have to designate certain ports to do it and so on. It's quite a entailed process to get it working. And then these are the STP things that you would actually type in on your assignment. And let's take a look at Ethernet channeling and then switch troubleshooting, and we'll be done. Okay, so Ethernet channeling combines multiple ports on a Cisco switch into a single logical link. So this is basically their way of saying, let's make trunking a little easier. Right, so that's basically what they're doing. They're creating trunk ports, right, and they're making it in 2 channels. So without Ether channel, only one link is used, and then with Ether channel, you can go back and forth between both of them. So it's Cisco centric. It has to be for them. And you got to run port aggregation protocol that prevents your loops, right? Because that's what you just created between these ports as loops. A loop right there. And then these are the commands for those. So that's why this one's listed. It's heavily used. Ether channel is heavily used, and it's a little beyond port trunking. And the last thing here in switch troubleshooting. On a switch, several things can happen. You can get a bad port. Lots of times that actually will happen when there's some kind of electrical storm, and it'll kind of blow that port out. You get some kind of surge down that line, and it kills the port. So how can you fix a bad port? You can't. So you either don't use it, or you send it back to the supplier and get a new switch. Now something that happens a lot, again, is what I talked about with STP, is you get a broadcast storm. And broadcast storms only happen when, for some reason, all the computers are set to broadcast, which hacking, somebody could hack and try to do that, denial of service attacks and such. That's the fun stuff we get to next semester. And so, you can cause a broadcast storm and take a network down with, various means. Anyway, and then you can reduce those storms if you're running STP to prevent loops. If you're not, then it's not going to help you. VLANs can be used to separate broadcast domains if that's a serious issue, but again, you have to think about where the traffic's going. If everyone in your network goes to 7 servers and everyone goes to those servers, then separating your traffic into VLAN is not going to help you because everyone is going to those 7 servers. If you've got 7 servers and R&D is constantly using 2 of them, but nobody else is using those 2, then a VLAN can help, right? It can help fix that problem. And so you really have to know that. I had a student, and he just would go through and, he went out and worked, and he'd create like 30 VLANs on these equipment. It's like, what are you doing? Everybody goes to these 4 servers you have. What good are you doing by separating the traffic? It all has to combine at some point. So he had a hard time understanding that. Anyway, collisions, of course, they occur when 2 devices share the same media segment and they transmit at the same time, which we've talked about. But that's what a broadcast storm is. So everybody's transmitting at the same time. But you can have some collisions. To eliminate collisions, connect only a single device to each switch port. For example, a hub is connected to a switch port, replace it with another switch. What they mean here is that sometimes you'll have a switch port and then it goes out to somebody's office. And then in that office you connect them with a hub. So you got 7 people all in that office, all hitting one switch port. And so what they mean is go out there and put a switch in. And then that way the switch is connected to a switch, and then the tinier switch is connected to your people. Now this one happens a lot, duplex mismatch. So when things come online, they try to auto-configure. And sometimes computers, if they have a particularly bad network card, will configure wrong. So they go through this auto-negotiation process, and then the computer comes up and says, okay, well, I'm 100 half. And the switch goes, okay, well, I'm 1000 full. And that's a problem. One's half, one's full. That's a duplex mismatch. And when that happens, you get really weird things. How you usually fix that is by going to the computer. If this ever happens to you and you're like, wow, this computer's just not connecting all the time to the switch, go in on the network card on the computer. So in Device Manager, go into the settings and force it and say you're 100 full or you're 1000 full, and see if the problem goes away. Because usually forcing the network adapter will then correct everything. Very slow network communications usually are what happens. It just keeps missing stuff. Frame errors. Frame errors or garbled frames are usually happens because a switch has a port that's bad or the network card it's coming off of is bad. And so when you have that, it talks about what it is, but when you have that, it means you go and you replace that network card in that particular computer. How you know it's happening is through these methods. Basically, if it's a smart switch, you can go and look and it'll show you, hey, on this port you're getting a bunch of frame errors. Sometimes you can actually just look at the lights and it'll just flash orange every once in a while and you're going, that's not normal. It should be always green. Orange usually means there's collisions or something's mutated the frame and it's not correct. And so it's not very common, but they're easy to fix. You see a frame error, you just go switch out the network card. Incorrect VLAN membership, so you actually put it in the wrong VLAN so it can't talk to who it's supposed to talk to. And slow link speed. And that can be caused by cables, by the network card being bad, by all sorts of different things. Usually a speed mismatch, but that's troubleshooting. Usually switches just kind of work. They just do their job, and if there's something to fix, it's usually replacing a network card to get it fixed, or looking on the switch and finding out they put them on the wrong VLAN or something like that. That is all of 6. So I don't know. That was probably as fast as what I usually do and personally, so sorry about that. Turn in notes for 6, and then I'm going to just be putting these out there. So all this stuff will be out there pretty early. So tomorrow I'll put 7 out there, and then I'll do 8, and I'll have all that stuff. And then later on I may have others that I need to add to it before you get to that section. But this is so if you want to, you can crank through the course and get the stuff done. I'll put the tests out there. Again, nothing after 5, but I'll start putting the ones that the final exam tests and everything. All right, so if you need help, let me know, and I'll have virtual office hours going on. Talk to you later.